Hi, dear students. Hope you are staying safe at home. And now I would like to continue for lesson 5. This is the last session, which covers pages between 143 to 146. The topic is strong and weak acids and alkalis. And first of all, we look at strong and weak acids, only for acids. Uh, Strong acids means complete ionized into ions with high concentration of uh, hydrogen. Hydrogen called protons are hydrogen cation in solution. If you have an acid which can ionize completely and produce a high concentration of hydrogen in a solution, we call a strong acid. Here there are some examples like hydrochloric acid, HCl, which is liquid form. When you put this acid to the water, this acid can ionize or separate completely for hydrogen, which is dissolving water, and chlorine, an ion in water. Another one is sulfuric acid. Sulfuric acid in water also can separate to hydrogen, and uh, it it produces a high concentration of the hydrogen and the corresponding uh, an ion. Another one is nitric acid, like uh, nitric acid. If you put this acid in water, this acid can produce a high concentration of hydrogen, hydrogen cation in a solution. If you have a high concentration of the hydrogen in solution, that means your acid is strong. On the other hand, you have weak acids. Weak acids only produce a partial dissolve into solution with low concentration of the hydrogen in solution. Okay, like ethanoic acid. You have, this is a kind of organic acid. If you mix this acid into a water, this acid produce hydrogen cation, and the corresponding anion inside of water or solution. But this hydrogen is not very high concentration. The concentration is low. Into the solution, you can see a molecular form of this acid. Okay, some molecular and some other can be separated to hydrogen and corresponding anion form. Not means that all this ethanoic acid can be separated to hydrogen and corresponding anion. Okay, but for a strong acid, they ionize almost completely. They produce high concentration of the hydrogen, but the weak acids, they produce a low concentration. That means not all the your acid will be separated to cation and anion. Another slide will describe you strong and weak alkalis. Same as acid, strong and weak acid. For alkalis, if the alkalis complete ionized into ions with high concentration of OH, hydroxide. Hydroxide, an ion in solution, you will have a strong alkalis. Okay, strong alkalis means the alkalis which produce a high concentration of hydroxide. Example of this case is sodium hydroxide, Okay, sodium hydroxide, which is form of the solid form. When you dissolve into the water, it almost completely separated to sodium cation and hydroxide anion. Okay, but this hydroxide anion will be a high concentration, so the alkalis is strong. If alkalis is weak, that means that alkalis produce a partial dissociated into ions with low concentration of hydroxide anion in solution, like ammonia. Ammonia is a gas form of a compound. When you dissolve into the water, it can be separated to cation and an ion. An ion form is a hydroxide. Okay, but it can be separated not at all. Just some of them can be separated partially and produce a low concentration of hydroxide. So that's why we call weak alkalis. There are two important notes for a strong and weak acid and alkalis is each pH unit means tenfold different in concentration. Okay, um, for hydrogen, the concentration of the hydrogen, which which can consider for acid, and for measuring the alkalis with whether it's strong or weak, we consider hydroxide. So for a pH, for example, we have two pH 2 and pH 3. Okay, pH 2, which is lower than pH 3, this is means more acidic, right? The pH 2 means more acidic than pH 3. And another meaning that we can get from this is pH 2 has 10 times more hydrogen concentration. Only one unit pH 2 is lower than pH 3, but this means pH 2 has 10 times more hydrogen concentration. Another example, you compare the pH 8 and pH 10. pH 10 is much more basic compared to pH 8, right? There is two more units for pH 10. So pH 10 has two more units compared to pH 8. That means you have 20 times more hydroxide concentration. 2 units more, that means 20. Okay, 20 times more hydroxide concentration. Each pH unit means tenfold difference in concentration of hydroxide or hydrogen in your solution. Okay, this is one important correlation. Another note is process of dissociation for weak acid or weak alkalis can be reversible. If you notice from the last slide here, when we were looking at for weak acid, here look at the arrow. The arrow is two sides. Means if you have weak acid or weak alkalis, your equation can be reversible, can be returned back after a while. When, for example, ammonia produce the cation and anion part of your solution, they can react to each other. Okay, they can react to each other, then return to the original form. Okay, these are reversible, it's not one way. But for a strong acid and a strong alkalis, a strong acid is a one arrow. Okay, one arrow, so that means they are not reversible, they cannot back. Okay, when hydrochloric acid produce the hydrogen and chlorine, an ion, these two ions cannot react to each other and uh, return back to the hydrochloric acid. This is one point that you need to take a look for. This two-way arrow is uh, representative for reversible equation. This is because a small number of, we said that partial ions can be produced. Here said a small number of ions have been produced and they can be recombined. Okay, products can be recombined and again produce the original form. Um, let's look at the neutralization and formation of the water. This is the original form of a neutralization. Acid and alkali can react to each other and produce salt and water. So far we were talking about the salt, but now just focus on the water. Um, Water is a result of a reaction between hydrogen ions, okay, which can be produced from the acid, and hydrochloric ions, which is result of alkali. Okay, for from the original form, I mean the basic reaction between acid, alkali, that we will get salt and water. So far we study about the salt, but from the acid, as we know, from the acid we can take hydrogen ions, and from the alkali we can take hydroxide ion. The result of these produced ions, we can get water. Here there is a kinematic of reaction. There is on the figure you can see that if you have sodium hydroxide and the result from reaction between the hydroxide and the hydrogen and cation here, if they react to each other, then you will get the water. But the reaction between the uh, metal and non-metal, these two, we can get the salt. We studied before the ionic reaction between acid and alkali, we can get the salt and water. The water is result of these two. The meaning of basicity of acids is that means how many moles of a metal can be replaced by hydrogen of acid. If you remember before, we learned that um, salt is the result of replacement of between hydrogen of acid with the metal. If the metal can react with the hydrogen, then we can get salt like here. Okay, but according to the number of the hydrogen which is replaced with the metal one, we can say that acid can be monobasic or monotropic. That means only one hydrogen can be replaced by the metal. If it's dibasic or ethane can be called diprotic. That means your acid has two hydrogen, and the two hydrogen can be replaced by metal. And if your acid has three hydrogen and all three hydrogen can be replaced by metal, we can call three basic, okay, or three protic. Here there is one example of diabasic is um, sulfuric acid. You have sulfuric acid here, and it reacts with sodium hydroxide. Okay, this sodium, which is metal, as I said here, this is metal, can be replaced by the hydrogen of your acid, as I mentioned here. Okay, first in one shot, the metal can be replaced with one of the hydrogen in acid. Here, as you can see, only one metal or one sodium can replace with one hydrogen. Here you had two, and now you have one hydrogen, okay, and produce another water. This is salt. And for the extra, if you add extra hydrochloric acid, uh, sodium hydroxide, like here two, so the all two sodium can replace with the other two hydrogen of your acid, like here. Okay, then later you will get more water because two hydrogen releases from released from the your acid. That's all for uh, today, and your the chapter 5 has been finished, and next time we will move to chapter 6. Please leave a comment down as your attendance for this video, and thank you for your attention. Take care.